Our exploration of space has left behind a hidden danger: space debris. Space debris, also called space junk, is a collection of objects orbiting Earth. These objects are no longer useful. They include old satellites, spent rocket parts, and fragments from collisions. These pieces of debris travel at incredibly high speeds. Even small pieces can cause significant damage. Space debris is a serious threat to functioning satellites. It also poses a risk to human spaceflight missions. As we continue to launch more objects into space, the problem of space debris is only getting worse. Understanding the dangers of space debris is crucial. We must address this growing problem. Our future in space depends on it. The amount of space debris orbiting our planet is constantly increasing. Thousands of satellites have been launched into space over the decades. Many of these satellites are no longer operational. They remain in orbit as silent threats. Collisions between these objects create thousands of smaller fragments, each posing its own risk. The European Space Agency estimates that over 130 million pieces of debris larger than 1 millimeter are currently orbiting Earth. Only a small fraction of these objects are tracked and catalogued. The vast majority remain undetected, posing a constant danger to operational spacecraft. This debris field is not static. It is constantly moving at incredible speeds. Even a small piece of debris can cause significant damage upon impact. The risks posed by space debris are significant and multifaceted. Space debris, also known as space junk, consists of defunct satellites, spent rocket stages, and fragments from disintegration, erosion, and collisions. This debris orbits Earth at incredibly high speeds, making even the smallest pieces potentially lethal. The most immediate concern is the danger to operational satellites. These satellites are crucial for a variety of functions that we rely on daily. These satellites provide essential services, including communication, navigation, and Earth observation. Without them, our ability to communicate globally, navigate accurately, and monitor environmental changes would be severely compromised. A collision with even a small piece of debris can disable or destroy a satellite, disrupting these vital services. The impact can create more debris, further exacerbating the problem. Human spaceflight missions also face considerable risk from space debris. Astronauts on missions, whether on the International Space Station or other spacecraft, are vulnerable to these high-speed projectiles. The International Space Station, for example, has had to perform numerous debris avoidance maneuvers to avoid potential collisions. These maneuvers require precise calculations and can disrupt scientific experiments and daily operations. These maneuvers are costly and disruptive. They consume valuable fuel and resources, and the constant threat of collision adds stress to the mission. The potential consequences of a collision with the space station are catastrophic. A significant impact could endanger the lives of astronauts and result in the loss of the station itself. Beyond the immediate dangers, space debris also poses a long-term threat to the space environment. The accumulation of debris increases the risk of future collisions, creating a hazardous environment for all space activities. The increasing density of debris increases the likelihood of collisions. Each collision generates more debris, leading to a vicious cycle. This could create a cascade effect known as the Kessler syndrome, rendering certain orbits unusable. If left unchecked, this could severely limit our ability to explore and utilize space in the future. Section 4. The Kessler syndrome, a domino effect in space. The Kessler syndrome, named after NASA scientist Donald J. Kessler, describes a catastrophic chain reaction in space. This phenomenon has the potential to render entire orbital regions unusable for satellites and spacecraft. This scenario begins with a collision between two large objects in orbit, such as satellites or spent rocket stages. The initial impact is just the beginning of a much larger problem. The impact creates thousands of pieces of debris, which then collide with other objects in orbit. Each collision generates even more debris, exponentially increasing the amount of hazardous material in space. This chain reaction continues, creating more and more debris. The cascading effect can lead to a situation where the density of debris becomes uncontrollable. Eventually, the density of debris in certain orbital regions could become so high that it would be impossible to safely operate spacecraft in those areas. This would severely impact satellite communications, weather forecasting, and even space exploration. The Kessler syndrome is not just a theoretical possibility, it is a real concern. Scientists and space agencies around the world are actively working on solutions to mitigate this risk. The increasing amount of space debris in Earth's orbit makes this scenario more likely. As we continue to launch more satellites, the risk of triggering the Kessler syndrome grows, making it imperative to find effective ways to manage and reduce space debris. Section 5. Combating the clutter mitigation efforts for space debris. Addressing the problem of space debris requires a multifaceted and comprehensive approach. One crucial aspect is mitigation, which involves reducing the creation of new debris in space. Space agencies and private companies are developing guidelines and technologies to minimize the amount of debris generated during space missions. These efforts include designing spacecraft for end-of-life disposal, such as deorbiting them into Earth's atmosphere or moving them to graveyard orbits, far from operational satellites. Another important aspect is developing technologies for active debris removal. This involves capturing and removing existing debris from orbit. Several innovative solutions are being explored, including nets, harpoons, and robotic arms. Section 6. A shared responsibility, international cooperation, and future outlook. The problem of space debris is a global issue that requires international cooperation. No single nation can address this challenge alone. International agreements and collaborations are crucial for developing and implementing effective debris mitigation and removal strategies. The future of space exploration depends on our ability to create a sustainable space environment. This requires a collective effort from all spacefaring nations. By working together, we can ensure that space remains a valuable resource for generations to come. Continued investment in research and development of new technologies is essential for addressing the growing challenge of space debris. Section 7. Protecting our future in space. The importance of continued action. Space exploration has brought tremendous benefits to humanity. From communication and navigation to Earth observation and scientific discovery, the advancements we've made are nothing short of extraordinary. Our reliance on space-based technologies continues to grow, impacting nearly every aspect of our daily lives. These technologies have become integral to modern society. However, our continued access to space depends on our ability to protect this precious environment from the growing threat of space debris. This debris poses a significant risk to both current and future missions. The consequences of inaction are significant. If we fail to address this issue, the impact could be catastrophic. The loss of essential satellite services such as communication, weather forecasting, and navigation would be devastating. The grounding of human spaceflight missions would halt our progress in exploration, setting us back decades. And the potential for a Kessler syndrome event where the density of objects in low Earth orbit is high enough to cause a cascade of collisions would make space activities nearly impossible. All these scenarios pose serious risks to our technological infrastructure, economic stability, and scientific progress. The ripple effects would be felt globally. We must act now to preserve our future in space. By raising awareness, supporting responsible space practices, and fostering international cooperation, we can make a difference. Advocating for continued investment in space debris mitigation and removal is crucial. These efforts will help ensure the safety and sustainability of our space endeavors. By taking these steps, we can ensure that space remains a frontier of discovery and progress for generations to come. Our actions today will shape the future of space exploration and its benefits for all of humanity.